So here we have a question about determine or find the interval where the following function is increasing, decreasing, or constant, and express your answer in interval notation. So to do this, you want to know where if the graph you're dealing with is increasing or decreasing. So what you do is I've got this graph in my graphing calculator, and it's x squared, it's a parabola. It's opening downward because of this negative here. It's been shifted to the left 2 because of this plus 2, and then it went down 2 because of this negative 2 right here. So here's your function. Now, if I trace this as I move left to right, and I'm always going to move left to right here. If I trace this, the x values will be increasing if I trace this because I'm moving to the x direction, positive, right? So as my x's are getting bigger, what are happening to my y values? I'm going to hit the trace button. You can actually see what's happening to my values here. As my x values get bigger, you see how it's -4, -3, -2, -1, 0, 1, 2. So you see how my x values are getting bigger and bigger there. Okay. Look at what happens to the y values. I'm going to go back around here. And you can see my little cursor. So as my x values increase, what happens to my y values? Look, they're increasing as well until I get to the vertex. Well, that's going to increase until I hit 2 because I shifted it to the left 2. I shifted this parabola to the left 2, so my vertex is now at 2. And then I went down 2. So my vertex is at -2. I went back 2, and then I went down 2. So my vertex is at -2, -2. So from -infinity to the value of -2, and I'm using my x values here, the graph is increasing. Then it begins to decrease from -2 to infinity. If I look at my values on the table, you can tell that's what happens as well. So as I go, look at what happens to my y values. They start getting bigger and bigger and bigger and bigger until I get to -2. Then what happens? They start to get smaller. Oops. So now my values are starting to get smaller and smaller and smaller. As my x values get bigger, my y values get smaller. That's decreasing. So this function is increasing from -infinity to -2. So I'm going to use my interval notation to do that. I use parentheses. I'm going to use parentheses in all these. -infinity to -2. It's decreasing from -2 to infinity. If something was constant, it would be a flat line. If it was increasing the whole time, it would be increasing to infinity. It would be just a straight line going up, or decreasing would be a straight line going down. This one I picked increasing and decreasing, and then I put in my two boxes there. So here we want to see if it's even, odd, or neither. And remember, if it's even, it has y-axis symmetry. If it's odd, it's origin symmetry. And if it doesn't have either of those, it's neither. So if you want to graph that, you need to hit Math, go over to Num, and ABS is how you find the absolute value. And you put the x in, close it up, divided by 4, and then plus 2. So the divided by 4 makes it compressed, so it's not as sharp, a sharp V, so to speak. The plus 2 makes it go up 2. Now if I fold this on the y-axis, it'd fold on top of itself. So it is still even. If I had moved this off of the y-axis, if I had any horizontal shift, it would have lost that y-axis symmetry, and I would have picked neither. So in this case, it's even. Alright, here we've got another increasing and decreasing question. And this one is based off of x to the 4th, which is a parabola. So what's going to happen here is this is a horizontal shift to the left 5. This is moving this is going to reflect it on the x-axis, so it's opening downward now, and this is going to move it all up 1. Move it up 1. So if I graphed it, it's negative x plus 5 to the 4th power plus 1. So remember, it took the original parabola that would have been here. All right, it moved it to the left 5. 1, 2, 3, 4, 5. It flipped it upside down, so now it's going down, and then it moved it up 1. So right here is where the vertex would have been at negative 5, positive 1. Negative 5, positive 1. So this graph here is increasing, then it starts to decrease. So where does it change over from increasing to decreasing? At negative 5. We're going to use the x value to determine that. It changes from being increasing at negative 5, and it changes back to decreasing at negative 5 on the x-axis. So we'll come over here and pick increasing, decreasing. Is increasing from negative infinity to negative 5, and it begins decreasing from negative 5 to positive infinity. That's how you're increasing and decreasing. It's on interval notation. That's why I had to use it that way. So here we have another function asking about increasing and decreasing or constant. Now this is m of x equals 2. That's the same thing as y equals 2. Now if you recall what that looks like, y equals 2, it's a flat line that goes through the y-axis at 2. I say flat, I mean they're all flat, but it's a horizontal line that goes through at 2. Well, this is not increasing or decreasing. It's neither, right? So this is constant. And what is it constant on? Well, it's constant along, oh shoot, it's not complete. Okay, good. It's constant along the whole x-axis. It's constant along all the x's. So it's constant on, I wonder if I can hit all the numbers. Yeah, along all the x's. I could have done negative infinity to positive infinity, but that works too. Alright, even, odd, or neither. Well, x cubed is automatically odd if it's the parent function. But now if I move it, if it gets shifted at all, left, right, up, or down, it loses its symmetry origin. And that right there, that plus 5 is going to move it off of the origin. It's going to shift it up 5. So automatically, well, not automatically, but then it becomes neither. It loses that symmetry. Let's try this one. Let's see, we're going to shift, horizontal shift. Negative 5 is a horizontal shift because it's inside the parentheses. So I want to go, it says negative, so that's to the right 5. It's backwards. Stretch, compress. There is no multiplying by fraction or whole number, so there's none. X-axis reflection. Well, that negative is a reflection, and it's on the outside. It's not on the x. It's out here on the outside, so it is an x-axis reflection. There's not negative on this x, so that's no for y-axis. And that negative 2 is a vertical shift down 2. It's the way you think. It says negative 2, so you go down 2. So this is what the graph should look like, this. All right. Now, domain and range. What's the domain? So we'll click on this previous answer here. What's the domain of this guy? I'm sorry, the original. This guy's what's asking for. Well, originally, the domain was 0 to infinity. I'm sorry, negative infinity to 0, and then 0 to infinity. That's what the original domain was. And since we shifted it horizontally 5, it's going to move that domain over to 5 units. So if you go back in your notes, find the original domain of the original function, then change the zeros to 5s. So that's what the domain is. Negative infinity to 5. Union negative 5. Oh no, 5 to infinity. Range. Well, now the range of the original 1 over x squared, the range originally was 0 to infinity. Well, you've done an x-axis reflection, so that messes with it, and then you've gone down 2 as well, that messes with it. So instead of it being from 0 to infinity, it's going to be negative infinity to negative 2, since you went down 2. It's negative infinity to negative 2. That's the y. That's as tall as it gets. All right, from negative infinity to negative 2. And we're going to use the parentheses around the negative 2. Negative infinities always go first. Positive infinities always go last. That's a negative 2. So I'm using that the original domain that I have in my notes where you memorize, and then you use that and this little guy right there, figure out how it changes.